relational databases in HDFS. Remember that HDFS stores chunk-based unstructured data, and Hive is not fully SQL compliant. However, many businesses have legacy relational databases that store structured information. So one solution is to use Hadoop MapReduce to speed up data ingestion, for example using extract, transform, and load pipeline, where first you extract data from outside sources, second to transform it to fit operational needs, and third to load it into the end target database. Vertica is a column-oriented database that supports a Hadoop connector, and today we're going to demo how to download data, Vertica, how to set up a test database, downloading the Vertica Hadoop connector, and a MapReduce code for loading data from HDFS to Vertica. Vertica speeds up data analytics with several enhancements. First, it organizes data into columns instead of rows for faster disk access. It groups columns together that are frequently co-accessed, and it enables data encoding and compression. You can find documentation for a free community edition of Vertica at this website, and instructions for setting up the Vertica database can be found in detailed PDFs. Just as a side note, the Obama 2012 campaign used Vertica to analyze voter data. So first, we can download the Vertica Community Edition at this particular website. You need to register and log in, and then you can choose your platform for downloading the Vertica Community Edition in Linux, Windows, etc. So first, we're going to install the Vertica RPM, and that's first by unpackaging the RPM. Second is running this install Vertica script. You have to do this as root and specify a username and a password for the database administrator. Afterwards, you can switch to that user and then run this admin tools function. In admin tools, there's a few steps. First is to choose the configuration menu that comes up, item 6. Next is to create a database by choosing item 1 and pushing enter. And then you can give it a database name like dbtest, some comments. Next, we specify the directory in which the database will be created, and we'll go ahead and create that database. Our next step is to download the Vertica Hadoop connector, and you can download this Hadoop connector from this following website. It turns out that the Hadoop connector as package is not compatible with Hadoop version 2. So here you have to download the Hadoop Vertica jar having found on this website for Hadoop 2.0. Then as root, you need to copy these jar files, the Hadoop Vertica connector, as well as the JDBC drivers, to your local Hadoop library folder. The documentation for this Vertica Hadoop connector can be found at this website. And basically the connector contains Java classes that implement input format, output format, and Vertica record for reading and writing data to HDFS. For example, in order to write to a Vertica table, you want to set an output value of a Vertica record class. You can configure the Vertica configuration so that you give it the database name, the port, the database user and password. And then you can set the output for the Hadoop job to the table name to write to, whether to replace records, and a list of columns that will be written. So this particular use case paradigm is using Hadoop and the power of distributed computing for extract, transform, load. Extracting from external data sources, transforming into a database-ready format using Hadoop and MapReduce, and storing these intermediate output files in HDFS, and finally loading this data using the Vertica data connector into Vertica. In today's example, we're going to do an extract, transform, and load of DNA frequencies into Vertica. The raw data provides positions of mutations, as well as the observed DNA nucleotides at each position. We're going to transform this raw string into a matrix where rows represent positions and columns represent the counts of A's, C's, G's, and T's. This is similar to a word count, but the words are particular DNA characters. And finally, we're going to load this data into Vertica such that when we do a select statement, we can recover the structured data. I've written example code in order to load this DNA frequency into Vertica. We're writing a mapper class only for loading HDFS data. This is the package, and these are the import libraries that you need for Yarn for MapReduce version 1. And these are the Vertica classes that are provided in the Vertica Hadoop connector. So we declare this matrix to Vertica class, and there's only going to be a map class. It's going to map from long writable to text, so it's going to go and parse through a text file with tab delimited separator. And then the output of the mapper is text, the table name that it goes to, and a Vertica record. So we initialize the Vertica record, and the map calls setup first, so we can create this Vertica record based on the configuration we specify. And then we're going to add the column's position and then counts of A's, C's, G's, and T's to that record. In the map function, once again, the input key is the long writable, the file position, and the text is the particular line that comes through in reading the file. What we're going to do is to use a string tokenizer to split the input line based on a tab. And what we're going to do then is to then read sequentially these 5 columns in the input line into 5 different tokens or 5 different columns. And then we're going to, what we're going to do in here is to write the tokens into different columns. And then we're going to create a new Vertica record, insert it into the variant frequency table, and this record will contain all 5 columns. Once again, these columns are position and then counts for A's, C's, G's, and T's. In order to run the Vertica job, we first have a getJob class that sets up the MapReduce job. The output value class is a Vertica record, and the output format is a Vertica output format. And what we have then is we use getJob to configure the job, and then we set the Vertica database that we're using, as well as the output Vertica data table that we're using. And then we just launch the job. So finally, we're going to actually compile and run this Java code. So if you take the zip file that is included, you can unzip the included features, and then go into the Hadoop Vertica connector directory, and you'll see a README file which describes the files that are included in this distribution, the instructions for installing Vertica and setting up the sample database, and some example code for the Vertica Hadoop connector. So in the example files, you'll see that there's a DNA counts matrix, there's a source directory which includes the Java class for the Vertica connector that's being called, as well as a jar file that I've made. And the Vertica includes folder has 3 files that you need to copy into your Hadoop main library or install. There are a couple extra files for doing the transform step of the extract transform load. These are the instructions for the Vertica installation, And note the example code. You have to compile the code and then package it into a jar and run the particular example code. So let's first compile the code. Would help by running that. Okay. Let's just make sure what we have in the input directory. Okay, good. Now we're going to run our jar file. And this is going to create a new vertica table. So let's make sure that we have a blank vertica table. So to run vertica, we type opt vertica bin vsql. You type in your password. And we currently have a variant frequency table. So we're going to drop variant frequency table, and then we currently have nothing there. So now when we run this Hadoop job, it will use the matrix to vertica class and read everything in input and populate the vertica table. So we're going to go ahead and launch this. So remember that there's only a map class here. And it's done. So basically it has loaded in all the records, loaded in the 500K file from HDFS, and written them into Vertica. Now to demonstrate that we do have it in Vertica, we're going to select count star from variant freq. That's 24,000 records, and we can show the first 10. And there we go. These are the positions and accounts for ACs, Gs, and Ts. Obviously, this is a small example because we don't want to overload your file system, but the nice thing is that this is now generalizable, so if we load in gigabytes of data, it should proceed relatively quickly. Thank you.